Great, I hope you can all hear me well. So hello everyone and welcome to today's webinar on floating wind supply chain challenges. My name is Gunnar Hölzig, I'm the Managing Director of the World Forum Offshore Wind. It's my great pleasure to welcome our three excellent speakers today. We have David Carrascosa from Saitec Offshore Technologies, Christof Dewijngaert from Bridon-Bekaert, and Bruno Geschier, normally with BW Ideol, but today in his role as chairman of WFO's Floating Offshore Wind Committee, and Bruno will be moderating today's webinar. So before we jump into the discussion and presentations, let me just tell you a few things about WFO. So we are a non-profit organization founded in 2018, representing the complete offshore wind value chain, and we have an international setup with offices in Hamburg and Singapore. And in terms of what we're actually doing, it's very straightforward. It's three things. We lobby for offshore wind by talking to regulators and policymakers around the world, especially in some of the new emerging offshore wind markets. We inform about offshore wind with reports and statistics that we publish, and we connect the global offshore wind industry via events, online events, as we do now, or actually hopefully soon again, physical events and conferences for people to really meet face to face. And in terms of our members, you can see an overview of all our members on the next slide, ranging from utilities to manufacturers, service firms, law firms, insurance brokers, other non-profit organizations. So really a great international mix of companies, big and small, from all parts of the offshore wind supply chain. And if you are not a member yet of WFO, please do join us and check out our WFO website, and feel free to contact me directly if you have any questions about how to become a member or the membership benefits. And then, since we're talking about floating offshore wind today, let me just quickly introduce to you our Floating Offshore Wind Committee, which is now already up and running for roughly 1 year, and it's been extremely successful. It's chaired by Bruno himself, and we're meeting on a quarterly level with our general Floating Offshore Wind Committee meeting, and then we have 3 specific subcommittees on specific topics such as insurance, moorings, and operation and maintenance, which meet on a monthly basis. And during those subcommittees, people really get together and talk in detail about those specific aspects and try to come up with solutions to really promote and foster the global development of floating offshore wind. So that was it from my side, and now it's my pleasure to hand it over to Bruno. Bruno, over to you.
Thank you very much, Gunnar. Thank you, everyone, for joining, to our speakers, but also to the audience. In addition to what you mentioned, with the subcommittees of the World Floating Offshore Wind Committee, by now the largest floating wind industry association in the world, we are also looking at other very topical and set up of very other topical subcommittees. One on electrical cables and interconnection, and another one dealing with the environment and the cohabitation with the other users of the maritime space. So 2 new subcommittees that will hopefully soon start working with our members. It's a very exciting time to talk about supply chain challenges with 2 distinguished speakers. David Carrascosa, who is has become very recently the director of operations of Saitec, a floating wind technology supplier, and Christof Dewijngaert, the general manager of Bridon-Bekaert Group's synthetics division, a company that has also been involved with floating wind very early on and working hard to contribute to that cost reduction and de-risking of the supply chain. It's the right time right now to collaborate because and to discuss supply chain challenges, because most of you are reading the news, are fully aware of very interesting developments with France's first commercial scale tender that was launched, with ScotWind, with what has been recently announced of Norway, and with Spain, and several of leading Spanish actors announcing their positioning on in floating wind and on commercial scale projects off Spain and the Canary Islands. Japan, of course, is very busy accelerating, and with the announcement of the allocation of the Gotos project to Toda, if my memory serves me right, it's 14 or 15 or 8 or 9 wind turbines of 2 megawatts for a total of 16 megawatt. And of course, the latest announcements by President Biden that will provide a very good push to the development of floating wind of California and hopefully of other parts of the US. So it is my great pleasure to, within this context, to host and moderate this webinar. We will have first presentations from both of our speakers, again addressing those supply chain challenges and at least what they see as there's some of the suggestions to address them. Those presentations will most likely last about 10 minutes each, and then we'll start a Q&A session and with the audience and with a couple of questions I've prepared myself. So without further ado, I don't know if a coin was thrown up and to see who starts, but well, it's Saitec that is seems to be ready. So go ahead, David, and perhaps briefly introduce yourself once again, because Director of Operation of Saitec is nice and short, but I'm sure you have a little more to tell us about you. Thank you.
Okay, thank you, Bruno, for the introduction, and thank you also for be the chair of these actually interesting, very interesting workshop. Yeah, my name is David Carrascosa. I'm actually a civil engineer by background, but in the early days I joined Saitec for the development of floating offshore wind, and I've been involved in this interesting activity for the last 8 years. So yeah, I've been involved actually in the whole process of development of our technology within the company. So just introducing very lightly, Saitec Offshore is actually a spin-off from a bigger engineering group called Saitec. It's a company dedicated to the development of floating offshore wind technology, and more particularly the development of our patented SaaS solution. We have now about 35 people within the company, fully focused on floating offshore wind, both in the technical and marketing and R&D activities. We've got actually quite a global footprint at the moment, with undergoing demonstration projects, but also, well, some developments and opportunities we are involved in several regions and geographies. So I think that's pretty much about the company, because probably the most interesting part of my presentation today is to speak about the technology, the demonstration project we are undergoing at the moment, and the supply chain we've got involved under, corresponding challenges, and we are looking at and we're facing at the moment from that point of view. So the SAF technology, for those who don't know yet, the technology is maybe kind of a disruptive technology made out of concrete as main construction material, having 2 horizontal hulls and a submerged plate linked to those hulls, and it's moored through a single point mooring system that allows the whole platform to rotate. So key point, concrete as a reduction, let's say a competitiveness producer, and reduce capex and opex when compared to steel solutions, and then the whole plug-and-play solution, which enables for a quick and fast and risk-reduced operation for the installation. But well, let's say that, yeah, that was just the intro for the technology. Now we want to present the flagship project we are working on, which is the DemoSat project, this 2 megawatt demonstration project. I'm actually introducing you through a short video. Said it's quite an important milestone for us. It's a project that will be installed off the coast of the Basque region. It will be actually the first platform to be connected to the Spanish grid, providing energy to almost 2,000 households in Spain, or the equivalent to the consumption of 2,000 Spaniards households. It's a project that will take place. It's taking place in its construction phase in the port of Bilbao, and the location site for installation is the Biscay Marine Energy Platform, which is a public infrastructure with all the permitting granted, and also the electrical infrastructure already laid. It's actually a very interesting project, obviously, but also for the region and obviously for the country. Said key milestones, I would say, is this, let's say, the rated power of 2 megawatt, 2,000 households as equivalent energy production, a very high level of local content, about 75% of the capex is going to the region and to the area close to the construction site, and yeah, 85-meter deep as a let's say location depth. It will be the first floating offshore wind platform connected to the Spanish grid, and it will be actually the third technology in concrete worldwide. So yeah, probably we'll go through a bit of the construction methodology and how we are putting this together, so you can then better understand the scheme for the supply chain and how local the project is being. So that's an overall view of the construction side as it is. We'll be sharing some photos afterwards, and this is just to represent, yeah, let's say the layout, which will include the precasting of several elements of the platform, and then a final position for the assembly of the whole platform. Good point is that the whole system will be assembled in the let's say in the port of Bilbao. Just to show you the process of how one of these elements or these pieces of the Lego are being pulled together. We're working with, let's say, standard concrete fabrication techniques and technologies, formworks, reinforcement, and then we just pour concrete and we pour concrete bifaces, introducing internal bulkheads inside of the hull to stiffen the hull. So that's actually the process we are following to cast these spectacular elements that will be afterwards assembled all together. And yeah, that's actually the stage where we are at the moment. So we are manufacturing, we are casting these concrete pieces, and these are really one of the latest photos that are coming from the site, the work site from last week. So things are starting to take shape. It's quite impressive. Bruno knows it well. I mean, Ideal went through these fabrication a while ago. It's our time now, and it's like impressive to see how how big these things are, and yeah, how massive the involvement of suppliers is required. Once the whole let's say arrangement of different precasted elements is performed, then we'll go through the assembly of the different elements. We'll place them on a reserved area for the, let's say, linkage of these different pieces, these different sections, and we will be putting together the whole system. So we'll have at the end of the day the whole platform, tower, and rotor nacelle assembly, everything assembled on top of the quay. So that's also showing quite an interesting approach and a, let's say, risk reduction approach, which might or might not be taken for the commercial projects, as probably for commercial projects we will be, the onshore works will stop at the assembly of the floater rather than installing also the turbine. But I mean, it's a way we're showing it's feasible. Once the whole thing is assembled, we'll load it into a semi-submersible barge to put that afloat, and then finally have it actually ready to be towed to its final location, then in Biomed, in the center we mentioned. Okay. So yeah, that's, let's say, a very quick look at the whole project and the whole process. Now we are looking at the supply chain. So we said we are having like a 75% of the supply chain or the capex being developed in a very local region. If we go to, let's say, particular, we are quite lucky to have quite a strength in the area. So in the area of Bilbao, I mean, we've got not only a huge port, but also quite a few very strong companies to provide services and let's say contract for this project. It's the example for Ferrovial, which is the construction company that's taking the lead for the onshore construction. Then BC9 Marine, you all will know them as a key provider for mooring solutions. Isaiah Wind as the, let's say, tower manufacturer. Auxema, it's a swivel manufacturer, and Ormazábal is a well-known company within the industry for electrical equipment. And let's say that even if it's, let's say, a reduced number of suppliers for the area, let's say that the key or most of the budget is going to these suppliers. Then we've got some further suppliers in Spain: ABB, Solute, Dejima, Actanis for the let's say for the installation, or Roderde for the bearings. But obviously it's not a, I mean, it's not a project we can develop with Spanish providers only, and that's why we are also engaging with some further international supply chain members, which, I mean, I've got a few examples here of suppliers we are working on with, like Bureau Veritas, Prysmian, Breihoff, Marx for the installation, Exco, Mita Technique for the controller, or Global Maritime for the marine warranty surveillance. So yeah, it's let's say that good thing is that, I mean, these concrete
accelerate a little bit, so we leave time to Christof also and to the Q&A. Well,
I'm finishing right now.
Okay, thanks.
So that's actually a very brief look at the different suppliers we have through the Demosat project, and a last slide about what's next. So we are now developing the installation and the yards for the upcoming commercial production, and that's what we are going to discuss probably afterwards through the Q&A. So I won't stop too much here, just to have a look at what we are required to build in these coming tenders, these commercial tenders. I've prepared I think quite a visual slide. We usually see the different let's say wind turbines being converted to the turret. We are yeah, let's say the Basque Country, and we compare that to the athletic club magnitude of a football pitch. So you can see like the map of these elements, and probably some of these challenges we are going to discuss afterwards will be related to the size and the area we need to develop these projects. And that's it from my side.
Thank you, David. And we look forward to address the challenges you've identified, because I think we know how complex it is with the scaling up. So we look forward to see where you see some of the key challenges and how you suggest not only you guys but the industry address them. Thank you. Christof,
hey.
your turn.
Yes, let me try to also get my screen shared here.
All right.
Is that coming through?
Yeah, looks perfect.
Okay, so also from my side, thank you for the invitation, and I'm happy to share some perspectives on supply chain challenges, but then from the perspective of more, let's say, not the system, but more the component or the subcomponent manufacturer view, and in particular for the mooring component. So I tried not to make this an advertisement for Bridon-Bekaert, but maybe just for your information, one slide to explain a bit the lens through which we look at this industry. Bridon-Bekaert, a bit, let's say, a combination of both sides of the story. Synthetics unit that I lead is a relatively, let's say, small, compact, agile unit in Scotland, running quite standalone and with a growth plan. So it's a bit this the SME view, or let's say the scale-up view to this whole floating wind opportunity. And what we do there is we make synthetic anchor lines, synthetic cables, with still very specific skilled labor, a lot of highly skilled operators there, but all in all a small team, less than 100 people. On the other hand, we do that as a unit or as a, let's say, a division in a multinational, Bekaert, who's our parent company, and who, you know, as many multinationals have their a world map with many dots on, listed on the stock exchange, and brings along this global multinational view to bring in coverage and participation in multiple geographies. So we have boots on the ground in a lot of these countries and markets you mentioned in the intro, Bruno. But at the same time, also from a product point of view, more than just the mooring lines, armoring for the power cables, concrete reinforcement. So there's really a whole portfolio of products. What they all have in common is that the mother company, Bekaert, is very much a steel company. So 99% of the revenue comes from steel products. And from that perspective, I think we bring a bit of a quite unique balance of, you know, both sides of the story here today. Now, when it comes to supply chain, and so for us as the synthetic cable part of the mooring package, so let's say subcomponent of that package, we often get a lot of, let's say, I would not say frustrations, but a lot of questions, at least from the industry, when it comes to steel moorings in general. This is a bit the weapon of choice for that first wave of demonstrators and pre-commercial farms. But where you know, the observations that customers make to us is, you know, capacity is tight. You know, this is a discrete process. You make one chain link at a time, so to say. Also, the supply scene itself is relatively tight. You always have a kind of an incumbent player and a challenger, but beyond two, you know, maximum three, but the landscape gets pretty thin rather quickly. To convince those people to add capacity, let's say, in the upcoming quarters and years to be ready for the middle of the decade is also not so straightforward. You know, all that metallurgical industry is quite capital intensive. You need furnaces and what have you. So Also there, a lot of discussion on business plans. And once you can leave the factory, then you enter into the realm of a new set of constraints or challenges. When you enter the port area, where you need indeed, to use a bit the metaphor from David, you need football fields in terms of storage space, preparation space, marshalling yards. And then still you need to find the right boats in terms of deck space and winches that can actually deploy all these big, massive steel mooring sets. Now, when we engage, and also, being predominantly a steel company ourselves, when you want to solve some of these dilemmas or these challenges, you obviously run into sometimes the corporate logic of, it's not easy to invest, or, the moment might not be there yet to invest now, as technologies are unclear, a TLP versus a SPAR, class societies are still in flux, where demand will appear first is still widespread. It's even in some cases not clear who the customer is. Will it be the operator or the floater, especially when you're a mooring component? Last minute it could shift as part of a broader package, or the package might get split. And add on top of all those ingredients also, let's say, a bit of sauce, that a lot of these people supplying these components today are making their daily bread and butter in oil and gas and offshore oil and gas industry, where the sentiment is relatively subdued for the moment. It quite quickly creates, let's say, a chicken and the egg situation, where I compared it a bit here for today's presentation with this Gordian knot. For those of you that don't know the story, it was a big entanglement, a big knot in Asian Persia, and it was rumored, or it's a legend that said, he who could, untie that knot or unentangle that, he would be the ruler of Asia. And it's with the same thing here. If you can solve all these, what technology to invest in, which location, which timing, which kind of customer to onboard, if you can figure this out now, I think it puts you in a very strong position to help the industry forward tremendously. But just a bit like with this Gordian knot, when you try to pull at it from different sides, sometimes trying to untie the knot, you only make it worse. Yeah? So you just tangle it even more. And I think the reflection we made as Bekaert and our synthetics unit within Bekaert is that sometimes doing more of the same will not get you where you have to be. And sometimes when you run into so much challenges throughout the whole supply chain, maybe the thing to do is to go back one step to the drawing board and to revisit the bill of material itself. And that's a bit what we've been doing. And that's also a bit how this Gordian knot thing got solved at the end, where you had Alexander the Great thinking differently and pragmatically. He just took his sword and cut the knot in half. And for us, anno 2021, that let's say today's version of that sword for us is really taking the courage and the adventure to step away from some of the proven mooring concepts that are out there in oil and gas, and actually to leverage other concepts, other solutions, and apply those on floating wind. To give you an example here, speaking for synthetic and synthetic moorings in general, I think when you compare it to the steel package that you know, or that you're all familiar with, you move from a discrete process to a continuous process. There's quite a bit of suppliers, I would say more than 10 worldwide. Capacity expansions, you don't need furnaces, but you end more into kind of light, fast textile-alike equipment where you don't need big foundations, so you can scale up with demand pretty smartly. In terms of pore space, you move from football fields to rather tennis or padel courts, so also there you enlarge the playing field quickly. And for the installation vessels, indeed, you easily go to local crews and vessels which are a tad smaller than what we have today for these massive steel structures. Also on the environmental side, as weights go down and as supply chains become more flexible, also there is indeed a significant benefit to observe. So from our side, what we're doing is we're integrating that thinking there, and also, we try to match that a bit with the needs of the industry moving forward. And for that, we took here, just to make a numeric example, that none of that is science fiction or so far, we took here a projection for, I don't know, the industry forecast And maybe there's even more optimistic ones if I listen to the introduction. But this one here stated that in 2030, at the end of the decade, there would be 2 gigawatt of capacity added that year. And 2 gigawatt, that will be roughly about 200 turbines, I guess. And with 3 lines of turbine, that's about 600 anchor lines. And typically, when people start to hear these numbers, we get a lot of questions, basically, what that means for us. And typically, the message we can bring there, at least from a synthetic point of view, is a message of reassurance. Because if you look at today, the golden triangle FPSOs, Gulf of Mexico, Brazil, you easily have their 20 lines, which 3 segments each. So, in terms of length, this would be about 60 lines for floating wind. So that means one FPSO in these regions, 10 of those would actually make up 2030 demand at the end of the decade. To put that in perspective, not 10 years forward, but 10 years ago in 2010 already, 26 of those got installed worldwide. And knowing oil and gas industry, well, if there's one thing they're extremely good at is making sure a plan B is available. So those years, that was not just a one-off, but in those years when FPSO boom was at its height, even then there was quite let's say, an omnipresent supply chain on standby, if you want, with almost a 100% idle backup capacity. So a second thought from my side here is that instead of sometimes revisiting the recipe if you run into too much trouble, I think a second message here is, and we see that a bit as Bridon-Bekaert very strongly, if you find the recipes and ways to unlock all the oil and gas offshore knowledge that is out there and the infrastructure that is out there, it probably can create a tremendous speed advantage in the whole race towards the middle of this decade. Obviously, with access and visibility on that offshore oil and gas demand, we're also the first to say that where wind demand will appear first floating is probably not in Brazil and Gulf of Mexico. So we, from our side, we also have a lot of discussions and reflections independently, but with customers then on where to deploy these capabilities and how to prepare those for the demand. And while we do so there, I think for that I borrow a bit the logic we have at group level at Bekaert, where we always have this balance between what you do local, what you do global, what you do central, what you do distributed. For that, also for cables, we work a bit along 2 axes. On the one hand, there is vertically, you see this here, how specific is the good? So how much particular raw materials or skills or equipment do you need to apply for that? And horizontally, how easy is it to move that product or that good around? And for us, the cables, they fall into the 4 quadrants. So we have, for the example, the elevator ropes, they are easy to move around and still we make them on very particular equipment. If you think about bridge cables, even, they're very hard to move around and then typically built even on site. For us today in mooring, especially synthetic mooring, the industry starts a bit in that bottom right corner, where these reels are huge, 4 to 6 meters. You don't travel by road. Typically, these factories are located also in a port or at the quayside, and still you need this very skilled, human skills and operator labor to make that, especially the terminations of those cables. And so you end up with a few regional or even global supply bases worldwide for those moorings. If we project that on floating wind, I think obviously the holy grail is if you can do something with that bottom left corner, because that's where you have kind of a global export platform, competitive economies of scale and skill. And the pattern where we're working along is to actually find a right decoupling point where you can have that bottom left, but combine it then or complement it with a kind of a temporary deployment during the, let's say, the capex phase of the project with a proximity finishing or let's say customization, so that when you have those 600 anchor lines and there's an installation anomaly or there's an installation damage, or if there's a last minute change in intolerances on other parts, that you have this reactive speed and that you basically have this proximity to the customer, not having to wait 6 weeks for material on a boat. So the view that we're taking here is to move a bit from that bottom right corner to a hybrid of the top and the bottom left corner. but also that is a discussion that is typically done, in close collaboration with, a full developer, because it actually touches upon the whole supply chain. And yeah, just as an introduction, I think that those were the three considerations as a component supplier. I again summarized them here. On the one hand, a lot of challenges, and we hear a lot of frustration, but from our point of view, it is supply chain starts a bit with what we want to supply, and there is a lot of opportunity to here not just copy paste, the conventional technologies, but to walk along a path with less obstacles. And in that path, I think we see oil and gas as a giant on which shoulders we can stand to look a bit further rather than a ballast. And when we do that, we are looking for the right decoupling points so that it's also for us easier to commit to the investments early on and upfront. And so that is something we typically do closely together with the rest of the supply chain, the customer base in particular.
Thank you very much, Christof. Very quickly, a first question to both of you. Scaling up. Christof, you addressed that a little bit. 1 unit, 1 floater is 3 to 6 or more mooring lines. Let's not underestimate the need for redundancy. When you are talking about delivering 50 units over and installing 50 units over a 2-year period, which is where we're going with bigger wind farms, bigger financial commitments that need to see revenue much faster. Where are the perceived bottlenecks and where are the real bottlenecks in your opinion? And first, perhaps for David, how do you see the industry? Because the key is our industry is more mature than many people think, because indeed we can leverage experience in the oil and gas industry or in some other industries. Having said that, oil and gas has always been the culture of one-off. David's technology with a single point mooring system and the turrets is one example. It's very rare that they have to install 50 units, produce and install 50 units over a 2-year period. So how do you see that scaling up, David?
Well, it's probably the big question, right? And how to tackle this is obviously something that we will be answering through the, let's say, the coming years. Our view here is, we are seeing quite let's say a request from the different governments and different public administration to involve local content through the development and the construction of floating commercial wind farms. Let's say ScotWind, Bridon Sud. We see that requirement, but for that, to be able to meet the requirement, we obviously need the supply chain. In our case, as a concrete floater, we see the powerful construction companies to be prepared to do this, but there's also challenges there. Some of the construction typical civil works have been more related also to one sole and unique structure. It's a bridge, or a specific bridge, very big bridge, but one single structure. And then we also need to introduce the industrialization aspect to it, and probably we will be able to provide local content for sure, but we also need to think about the potential, at least for the first floating offshore wind farms, to distribute the contracts over several regions, also to get to a point where we got the wind farms installed in the timing we are requested to.
Mm-hmm. And that is for concrete construction, which obviously I'm very familiar with, and I know that we can really parlay and leverage the proven expertise of civil engineering firms. And like we're seeing it today in the construction of the Fécamp fixed bottom and the gravity-based foundations in France. However, what about key components? We saw the flexibility and the benefits of synthetic ropes versus chain link, without a doubt, both from a cost and from a logistics point of view and from a supply chain availability point of view. And what about key components like transition pieces or turrets and single point mooring systems? How do you see that? Do you see a bottleneck? Or some actions that need to be undertaken to be ready by within the next 3-4 years? Because again, the large commercial scale wind farms will not be built starting 3-4 years or 5 years from now. So do you see, how do you see at solving those kind of issues, or are there no bottlenecks there?
No, yeah, it's an interesting question, as many would think, and many would question the approach of using a single point mooring. The truth is, the arrangement is inspired obviously in the oil and gas field, but it's not similar at all in terms of the details. So for a single point mooring, for a turret system for oil and gas, we've got the need of transferring oil, gas, telecommunications, and then you've got a small part of the swivel that also transmits electricity. This is actually quite different when compared to an arrangement for a floating offshore wind unit, and then we need to look at the swivel itself only, which is the, let's say, the rotating connection for the electrical transmission. And for those, we've identified several suppliers that could provide a great number of or let's say be aligned with the production of, let's say, even one platform a week or one platform each 2 weeks. It's not a huge bottleneck what we've identified there. The turret arrangement is more of a, let's say out of the shelf steel construction, so not really a challenge there, and probably we'll see more challenges in the in the more generic and shared points, which is the areas required for the ports, heavy lifting, installation vessels available, that's also something that's coming from the oil and gas. Probably more on those, but probably we'll discuss that afterwards, right? So, yeah.
Thank you. So no relevant bottlenecks on your end, and that is good news. Christof, in terms of harbors and ports, of course, the benefits of having ropes on reels is a great logistics benefit, not only for storage space at the harbor, but also on the ship and on a vessel. Do you who has observed the industry for quite some time and travel a lot, do you see some key challenges in the harbors from a supplier point of view, key component supplier point of view? And I'll ask the same question then to David later in terms of construction. But from supply chain point of view, do you see issues there, storage capacity issues, or other issues that could hamper or challenge the on-time delivery of floating offshore wind installations?
To be honest, I see rather opportunities than challenges, because indeed all the advantages, all the benefits that you mentioned are definitely there, but we have still typically seen that supplied from these few global FPSO offshore supply hubs. So whenever the reels arrive somewhere, they do that after a long ocean journey. Again, where you need protection against the ocean conditions in terms of strength, in terms of marine environment, also in terms of the environmental impact again that creates. In the world where demand will not necessarily be 2,000 meter length lines, but shorter lines, more compact final product packages, it opens the door for novel, let's say, final packaging technologies and techniques that are even more cost competitive, I would say, easier to handle, and probably allow for even more benefits at the end user level compared to what we have historically seen for oil and gas. When doing that, obviously, I think there is indeed one attention point or something where we're working together with, let's say, each time customers, whenever we deploy, where we deploy, but we did not mention that in the intro, but we have as Bridon-Bekaert our own Ropes 360 service team, providing installation support, inspection. It is obviously the case that a lot of the port environment, are very rugged, let's say harsh environment, but where the sophistication of a synthetic rope requires sometimes a bit of attention during storage and during handling. And for that, we do the first ones together. We do that side by side, but then the teams they run with that and they play with that. So from my point of view, opportunity rather than bottleneck. Maybe if I can just maybe say on the previous question on the scaling up, coming back to that. I think there I gave a bit of optimistic picture with the oil and gas capacity also existing out there, 26 FPSOs, while maybe demand in 2025 for floating wind equals 10 or double of that. But I think for us, the scale up journey is clearly not the equipment, to secure a lease of some land or to put an industrial building. None of that takes 3 years nowadays. Also equipment-wise, being part of Bekaert, we are a relatively vertical integrated company. We have our own engineering team, building our own equipment, and at any given point in time, our group is putting 2 to 3 new factories somewhere around the world. So that is what we do, as part of our daily bread and butter. However, on this case for synthetics, where I think it requires consideration, it's more on the human aspect and on the operator aspect. It's to prepare the skills, the workforce that knows the details, the handling, the procedures, and that actually runs those products at top-notch quality first time right through the factories. And to prepare that well ahead of time with the right mileage, I think that is a bit where we look at it in terms of scale up. It's not so much the hardware, it is rather the soft side of it.
Okay, thank you very much, David. With wind turbines getting bigger and bigger, I mean, we're all working on projects now with 14 to 16 megawatt range, and we're hearing and already looking at all the way up to 20 megawatt. You're seeing floaters, not all luckily, but some floaters that are getting bigger and bigger, and that of course leads to challenges in terms of constructability, launchability, storage of the finished units. How do you see that? Where do you see the challenges for floating in general, and in particular for your technology, as again delivering 50 units over a 2-year period is quite a remarkable feat that we will need to accomplish and that the industry will need to accomplish. But how do you see that scale up in a harbor context? And there again, that is, it's really looking at that in a harbor or a yard context today. We hear about using multiple harbors, some for construction and launching, other ones to install the wind turbines. All those things are feasible and are, of course, very relevant to the local context and local limitations eventually, or local obligations. But how have you tackled those challenges as a company?
Yeah, it's obviously the question, right? And I would like to start by say when we developed these, we first developed these industrialized construction process and so on. We actually took an area of the port, and then you start to develop your footprint and so on and so forth. That was, let's say, in the early days. Now you realize several key points here. And one of the key points I would say is the fact that construction of floating offshore wind within the port area is not the big business for the port. The big business for the port is the transfer of tonnage, and that's the business cases of the port are are related to the tonnage they move through the year. It's also obviously an advantage for the community, the amount of local employment you will generate. But there's that discussion there. So we won't have like infinite yards or hectares to locate our construction yard, and that's why we need to think, depending on the location, depending on the country, and depending on the contour conditions. We need to develop different opportunities, and for our specific case, we are now developing process for different, let's say, case studies. So also for different developments we are being involved in, and those include, well, the full construction. From the full construction of the platforms in the port area, to the, let's say, the delocalization of probably the precasting process, so we can precast parts of the floaters elsewhere, and then having a, let's say, a hub of assembly for both the floaters and turbines, and then the commissioning, the onshore commissioning. So yeah, we need to. It's a question that will need to be answered case by case, in geography by geography, and project by project probably, and then we need to be prepared to provide solutions for the cases where we won't have an area enough to spread everything. Let's say having storage, precasting, casting, and everything in the same place. It's probably the ideal, but won't be the case for the, let's say, the general probably project or typical project.
How do you see the challenges of steel construction? Of course, the idea here is not to oppose concrete to steel, but to see, eventually highlight some of the benefits of using concrete in a large scale project, in a commercial scale project, and also again the impact of the floater's dimension when fitted with a 15 or 16 megawatt wind turbine. Where do you see the key bottlenecks, or the benefits of concrete and of compact solutions?
Yeah, we see, let's say, these. We're seeing this project where we can go for let's say pre-commercial wind farms where you can more or less build your 3 to 4 units in a single shipyard. Then when these numbers start to increase, well, there will be a challenge, obviously, that technology developers for steel will need to face. Probably this multi-shipyard approach is something they will need to approach, probably reducing the local content for the different constructions and the different opportunities we will see in the near future. I don't think that's impossible, but it's obviously an advantage. You will see selecting compact and concrete based solution, so you can generate let's say the project in a much more packed let's say supply chain network and local network. And if we speaking also about advantages or disadvantages these days, it's probably worth pointing out to the price of the raw material, right? So let's say the advantage of using concrete and also for these projects we are developing now and will be constructed in 7 years, the security you will have in terms of your prices, your capex, if you use concrete compared to using steel, well, I think that's also an asset we need to emphasize.
Thank you. We have 5 minutes left, and I see questions coming in, and one in particular that is more linked to installation, which is something that is very important. Also, there's a difference between installing 1 floater and again installing 50, especially in areas where there is very good wind, which often means also reduced weather windows, because big wind often means rough mid-ocean conditions. So, Christof, as an observer of offshore installation, being a supplier of one of the key components there, do you see some challenges in terms of, where do you see the challenges in terms of offshore installation? I would call serial installation. This is something we address at the Floating Offshore Wind Committee, of course, but where do you see that as an observer? And perhaps have David to finish that very briefly, because it's indeed something that cannot be neglected. Of course, every floater is different. The pre-laying of the mooring lines and depending on the mooring solutions that are chosen can take more or less time. Same for the anchor solution, can take more or less time. And then the hookup is also a very key and delicate operation. So very quickly, your opinion or some of the challenges regarding offshore installation.
Well, I think so far we're doing it the way we've always done it in oil and gas, and I think the potential is still there to definitely optimize that and reap again a lot of benefits. I think this is public secret, but the key topics to work on, well, you can pre-lay, so you take it off the critical path and you do work beforehand. But the pre-lay can be optimized quite a bit with wet storage, making wet storage possible by improving the tensioning or retensioning functionality. And then the other item, which is a battlefield today, is actually also the disconnect, because a lot of the systems are easy to connect, but we have to plan ahead and factor that in. So my answer would be, let's bring the technologies forward that are possible today and demonstrate these in the field. But nothing in there that is intimidating from a component manufacturing point of view, to take it off the track and do pre-lay and pre-storage.
Thank you, David.
Yeah, just emphasizing that TNI logistics will play a key role for floating offshore wind commercial projects. We'll see projects where construction site and installation site are quite far away one from the other. So also looking at towing speed, looking at the strategy of relaying as much as you can, and the quick or fast you can hook up the different technologies will also play a key role in the selection of the technologies, also depending on the project.
Thank you, David. Well, as a conclusion, and thanking you again for your contribution, I think what is very important is that, yes, scaling up and embracing commercial scale deployment still has a few challenges, but no challenges that seem to be not under control or that cannot be addressed using proven and time-tested technologies, methods, and process. It is very important for our audience, again, to realize once again that floating wind is not research and development. We've passed that. Floating wind is, since countries, since major players, utilities, oil and gas companies are willing to take risks and invest billions in developing and executing commercial scale floating wind farms, it's a sign that the industry is much more mature and much more ready to accelerate than most of us think. We've not been able to address all the issues of the supply chain. It would have been great to also have someone from the wind turbine environment on board, but this will just leave us the opportunity to organize more of these webinars. And but again, floating is now, floating is tomorrow, but already now floating is increasingly popular, as you know, and it's not for lack of insisting on that message for the last few years. but I can only say we told you guys, we told you so. And now let's take a final moment to thank our audience, and we know that within our audience, a lot of members of the supply chain, and without them, we would not going very far. So thanks again for all those visionaries that and also the utilities and the developers that have seen floating wind coming, that have invested in floating wind over the last few years, are the ones that have finally realized and admitted that it's about time to get heavily involved. So thanks to all of those people, and I will not say may the best win, because at this point in time there's plenty of business for everyone, at least for the bankable technologies. Thank you very much. Perhaps a final thank you from to Gunnar and his team, and perhaps from Gunnar to the rest of the audience.
Perfect. Thank you very much, Bruno. So I can only echo what Bruno just said. Thank you very much for this excellent discussion and the great presentation. Thank you very much, everyone, for listening and joining us today. And the rest of the day, thank you very much. Goodbye.
Thank you. Best regards. Bye-bye.
Thank you.
Take care.
Take care. And good luck with all the upcoming tenders to all of you.